and welcome to this masterclass. And we invited our friends and partners from Pupil Labs to do this masterclass with us and learn a little bit about eye tracking and the future of eye tracking, like it says on your website. And we're here with the Pupil Labs founder, and with the titles I'm always struggling a bit. So Moritz is definitely one of the two founders I know, and
yes.
I will put some links always in the chat so you know what we're talking about. This is actually Will, the other founder, and I wanted to go back to the homepage. So pupillabs.com is who's visiting, and iSquare is the host of this session. We are partners, so we use and work with Pupil Labs for a long time. We do the market research, so we use eye tracking very different settings and varieties, and are really happy to have you guys here since you built this great product from scratch. And I'll kind of hand over to you, Moritz, to introduce yourself, since you can do that better, and also your colleague Neil. And I'd be happy to listen to you now for a second.
Yeah. All right. Thank you so much, Philip. It's a pleasure to be here in this masterclass. I'll do quick introductions of who we are, who's here from the company, and then I will briefly introduce the company backstory, go into the product that we'll do a quick demo on today, and then we'll dive into Pupil Cloud and the enrichment functions that we have there. If there's any questions in between, just raise a hand or use chat. I'd be happy to answer anything in between. I think let's make this interactive so that there's more benefit to being live. So I'll just get started. I have 30 minutes today. I think Neil can stay on for a bit longer for Q&A. He knows the product almost better than me nowadays anyways. So, and also, let me just jump into introductions here. So my name is Moritz Kassner. I founded Pupil Labs together with Bill Patera in, I would say, something like 2013. So it's almost 9 years now. We've been doing nothing but mobile eye tracking. Pupil Labs' mission is to bring mobile eye tracking into the real world. We started doing this by having a focus on accessibility. So the first problem that we were facing was that eye trackers were very expensive, closed systems, and they were really only usable by a few people with trained operators. We changed that in the beginning by making Pupil Core, which was an open source eye tracker that we started selling for a tenth of the price of normal eye trackers. That was really kind of resonated very strongly with the academic world and still does. So Pupil Labs' main user base is academic research. I think we are, by nowadays, what I've been hearing is that essentially we are the new standard for eye tracking research, mobile eye tracking research in academia. So once we do accessibility in terms of pricing and openness, then the next thing that comes to mind with accessibility is ease of use. So eye tracking generally requires calibration, trained operators, and setup. We then went on to launch second product, and that is the second product that we made, and that is Pupil Invisible. It looks like this. So it looks like a normal pair of glasses. And when I put it on like this, it looks like a normal pair of glasses. So I can walk down the street and not really be perceived as wearing a research instrument on my face. We have a detachable scene camera. This is this. It attaches here magnetically, and then there's a cable that goes to my companion device. So this is what actually runs. The algorithm provides power and all of that to the glasses. The glasses themselves, they look and feel like normal glasses. They don't have hinges, but they have small eye tracking cameras here and there. So these are small infrared cameras. They run at 200 hertz, and they capture my left and right eye. What's special about this compared to a traditional eye tracker or our Pupil Core system, which looks like that, is one, is it doesn't look like a research tool. This does, right? And there's nothing I can adjust here. So I put this on, and I don't have to worry about doing any mistakes because there's nothing I can do wrong. And the second thing is that a system like this and also other systems on the market essentially require a calibration step. This here doesn't. You can put this on anybody and you start the companion app. Looks like this. I don't know if it is so visible. And this red circle shows what I'm looking at. And clearly right now I'm looking at myself on the screen. I didn't have to do any type of calibration. I could give this right now to Philip. He could put this on and work the same way. And the way we do this is because there's a neural network that has essentially seen thousands of people's eyes before and been trained to detect gaze estimation with no calibration on anybody. And this gives us essentially a calibration-free system, a system that works on a really broad range of physiologies, across a broad range of physiologies. And then another thing is that with neural networks, they are by nature extremely robust when they have observed a lot of challenging environments during their training. And we have trained this thing in the bright sunlight outside in different conditions. And this means that this is also very robust outside, which is novel. So this is an eye tracker you can take into the real world. You can use it in real world scenarios. It's highly accessible. That's sort of in short what we're doing.
And it really works. I mean, we have just sent, I don't know, 30 of them to Canada, to people's homes for, I didn't think it would actually be possible, but we can get to these scenarios later on, and I don't want to interrupt you guys now.
Yeah, sorry, and I completely broke with my own protocol. Julia Mansa, I will, one sec, yeah? I will just briefly, I wanted to first also introduce Neil. So Neil joined us a couple of years ago. Neil is the lead product specialist. He comes essentially out of academic research using eye tracking for a lot of motor control tasks and experiments. So he is really a person that knows how to conduct research with eye tracking tools, and he now works at Pupil Labs, essentially sharing and educating users on how to use these tools in a research context. And he can also basically answer any question that you might have about the tool. So yeah, Pupil Labs as a whole, we're about 30 people. We're a small company, but we're very focused on making this one thing, which are these mobile eye trackers. So the nice thing about a tool like this, and this is why in a masterclass I can cover a lot of ground, even if the masterclass is short, there isn't so much you need to know to get started. The sort of the bring up period for Pupil Invisible is much shorter than for something like this. With something like this, I would have to tell you and teach you how to do calibrations, things like that. With this, I can essentially just say, have your subjects know how to conduct a study, but the technical aspects are relatively easy to do. So you put on the glasses, you have a record button, you just start your recording. And now we're capturing the data on the device. And when I'm done with my recording, I just click stop. I can immediately preview. So I can immediately watch my data afterwards. I can say stop here, save this, go into my recordings. And now I'm just playing back what we just did. It's relatively boring because I was doing this, looking at the screen and gesturing. But I have this immediately visible. So I can immediately, after doing my study, I can review the quality, and two, I can walk my subjects through an interview situation and essentially just show them what they did and then ask them questions about it if I want to do this kind of qualitative research. And that is more or less where the story ends for qualitative research. So we have this, almost, but at the same time, because it's configured this way, you can see this little cloud check mark. We have now uploaded this recording into my private and secure Pupil cloud account. And I can do this because it's a phone. If I have a mobile data, I could do this from anywhere in the world in any situation. As long as I have a mobile data, I can basically upload all the subject data that I have into the Pupil cloud account. And now I wanna apologize because there was a question. So there was a raised hand. Maybe we interject here quickly and take that. Is that in the chat?
Might have been me, but please go ahead if you guys have a question.
Okay.
You can also unmute yourself, but we'll also have time for this in the end. And no, then go on, show the cloud. And I guess the cloud is now where you also do a lot of developments like in parallel. So I know the hardware is also being constantly optimized and the algorithms, but the cloud is really interesting for us too.
Okay, fantastic. Julia, do you still would like? You just came on video, so maybe you've been waiting.
A question, but we can also do it afterwards. Doesn't matter.
I mean, maybe now that we're here.
Okay, good. Now, so I was wondering about this calibration. So you were saying you have a neural network doing the calibration postdoc. During my academic research, I actually had to do some calibration afterwards, but I was able to know more or less where subjects were looking. So I was in front of a screen. So that was kind of easy. Sorry, I was wondering if you could explain shortly, because I find it extremely fascinating how this calibration works.
So, I mean, I'm not sure with what system you worked, but
it was an iLink 1000. Okay. So,
All right. So there isn't really any calibration. So you, for a lot of use cases, it's totally sufficient to use the accuracy that the system comes with out of the box. There is a type of subject-specific calibration that we can do, but that is something I can do either via the app or I can do it after the fact. But I would have to utilize a type of protocol in which I basically instruct the subject to look at a certain point in the world, note that they're looking at that point, and then after the fact, basically check that they're looking there. I can also do this in real time in the app, called the offset correction.
But you still need to check the visual input you get from your camera, so the world outside to where they're looking, right? So you need to match those two images, don't you?
Maybe we can jump into a little demo. So basically, when you turn on the camera, and Moritz showed it before, the prediction of where you're looking at is automatically starting, and the neural network predicts where you're looking at, and there's not even a 1-point calibration like Toby does. It's actually like a 0-point calibration, and the eye tracking is there immediately.
Yeah, so there's no calibration necessary. What I can do, however, is I can pick a landmark. I'm not sure what I should take. There's a little projector at the end of the room. I'm going to look at that. So let me just. So this is going to be a little bit tricky, but I can do a type of calibration where I can freeze the video. Now I instructed myself to look at the projector, and I can make a small adjustment here. And then I can just continue operating and I apply this. This is what we call the subject-specific offset.
Awesome. Maybe we'll have to post this in the infos as well. Pupil Labs, I'm just gonna show it now since I think about it. You guys have a great website and great documentation. Right now, I'm in here in the Pupil documentation, and there is really everything you need to know about eye tracking in details as well. And the publications are great, and also the Discord channel is great. And I just found Neil in here as well in the Discord channel. Like, here is really the expert forum where you can ask like crazy detailed questions. And so I'll put all of these links later on in the show notes, and then we'll hand over to you guys to show the cloud before. Yeah, we still have some time.
Yeah, we're racing through the program here. So, so just to go back to the logistics. So in eye tracking in general, I think anybody that has run a bigger study with eye tracking knows that data logistics is sort of a pesky topic. If you do 200 subjects and you need 5 different, let's say the recording data, some metadata that you want to keep, which you maybe organize in an Excel sheet that your operators have, plus a questionnaire, plus your subject ID. So that's 400 interactions for 100 subjects that need to all go flawless. Otherwise, you have data loss. And we tried to solve this part as well. So we have Pupil Cloud, which has automatic uploads. It's amazing what happens when you have really low latency between when your data is collected and when your experts in your headquarters essentially can start reviewing the data. Because then all of a sudden you have a very quick feedback loop. So you can quickly see if your operators in the field are making protocol mistakes, or if there's stuff that you want to optimize that you want them to emphasize again. This can happen once you have this real-time, this near real-time, data collection feedback loop with Pupil Cloud. Then we have what we call templates. That's every single recording. Also, you can essentially add a little customized form into that, so you can collect all your metadata either by your operator or by your subject right then with your recordings associated with the recording. And then obviously we have subject management, so that you can have either real names or subject IDs for every subject that you can create ahead of time. And then you just go into a list here in the companion app, and you pick what we call the where. So right now it's me, but this can be changed. And we have, for example, here, these are like subject IDs that were used for study, or some other wheres, right? So this workspace here, we have workspace management that has a bunch of wheres, but obviously you can also set it up so you only see the wheres for the study that you're currently running. So this is logistics. It all works in cloud. Anybody that has access to your data, that you can share and distribute, can download the data and you can review it in cloud. And I'm going to hand it to Neil. Maybe Neil, could you open our demo workspace? That would be fantastic, because he's way better at walking through that. Maybe while you share it, I'm going to briefly just give some context. Neil, you can screen share, right, Philip?
Just trying to now, yeah.
Yeah, I think you should be able to.
So what we're going to do now is Neil's going to walk you through one of our demo workspaces. Demo workspace simply means, so there's a project that we did. It's a demo project. We had one of our colleagues, Neil just dropped out, right? Well, I'm going to continue. He's going to come back. We had one of our colleagues conduct a small study, a micro study essentially, in a gallery, where he had 5 subjects walk through a gallery and look at different paintings. And so we collected this data. It was uploaded to Pupil Cloud. And once you have it there, you can, okay, Neil's coming back, fantastic. Once we have it in Pupil Cloud, you can share it. And we actually have permission from the subjects and the gallery to share this publicly. So anybody in this call could, if they wanted to afterwards, go to cloud.pupil-labs.com, create an account. And then once you have an account, there's a little menu item at the bottom for your profile. Maybe could you show just how to access the demo workspace, how to switch workspaces? That would be fantastic.
Yeah, 1 second. Okay.
There you go.
Right. So this is what you're seeing is the drive view of a Pupil Cloud. So this is what you'd get when you log into Pupil Cloud. And so all your recordings live here, and you can play them back and things like that. And down in the
this is Neil, this is your account, right? And then you're currently in the demo workspace.
Demo workspace, yeah.
Can you show, just for anybody, if they were to make now their own account, could you show how to switch into a demo workspace?
Yeah, so down in the bottom left here, you get this. If you click on the icon, the user icon, you'll get the option to switch workspace. So these are quite a few different workspaces that I have access to, and you'll find in your account there's this option here that says demo workspace. If you click on that, it will take you to here basically.
Awesome. Now I found it too.
So yeah, anybody could, after our call here, just make a Pupil Labs account. It's free. Switch the workspace into the demo workspace, and you can exactly recreate and relive everything that Neil's going to show you now.
Great. So yeah, once you've got into the drive view, you'll see a lot of different recordings and lots of different names and labelings. So the data that's living in this workspace was collected by one of our product specialists, Richard, in an art gallery in Aarhus in Denmark. And essentially his participants that people that he was working with went into the art gallery, walked around, looked at various different pieces of artwork whilst wearing the Pupil invisible glasses. And essentially everything is living in here. All the recordings are stored here, and we're also doing some analysis on the data. So I'm going to show you that. So firstly, let's just quickly play back one of the recordings. So we'll go for Stephen walking around upstairs. So you can play back the recordings in the drive view. Okay. Can you hear the audio on that? Yeah, yep. Excellent. So there is an onboard, Pupil Invisible does audio capture. So if you want to record that, you can. You can also disable it if that's something that you don't want to record. Yeah, so this is somebody making their way around this nice art gallery. And immediately we're getting like a really nice high level insights into what's attracting the wearer's attention as they're walking around. In this case, they're not looking at the artwork, but actually they're looking at a description of the artwork down in the bottom right there, which is quite interesting. They seem to attract a lot of attention. And, you know, traditionally now, the approach to kind of gaining more quantitative insights would be to start going through these videos frame by frame and maybe manually annotating where the wearer was looking. In this case, you know, this piece of artwork, looking at the eye, maybe looking at a different point of the artwork that you may have identified some things on it that you're interested in coding when and where the wearer was looking, basically, which is quite time consuming, right? You've got to go through frame by frame. And if you have multiple participants collected, you know, walking around looking at various pieces of artwork, it's going to take some time, isn't it? And it's also, you know, prone to human error. So you might have to get one or two coders to actually go through the kind of video sequences and do this analysis. So we like to, at Pupil Labs, think kind of out of the box and come up with ways to make life easier for researchers. I know during my PhD and postdoc, things were done the old style, and yeah, prone to a lot of kind of time, cost, and human error. So I want to show you one of our enrichments that we have in Pupil Cloud that aims to get around some of those constraints. So I'm going to jump into projects, which is another part of Pupil Cloud, and you can get to projects in the top left here. So this is the drive icon, this is projects icon. So I jump into a project, and you can, for example, select some recordings and right click and create a project with your own data. But in the demo workspace, we already have projects that are set up with all the analyses contained within them for you to have a look at. So yeah, please try and kind of follow along with what I'm doing now, but you can also have a look at all this stuff yourself in your own demo workspace. So in projects, I've loaded Stephen's recording, and you'll notice that there are lots of little points down here in the timeline, and these are events. Events we use to essentially identify important points in the recording. For example, when one particular participant was kind of approaching a piece of artwork here, and maybe when they've left the artwork. And these are already here for you, so you can open this little menu here and click on jump to time and click play, and you can see this individual is approaching this piece of artwork, which is called Christopher Blanc, or by Christopher Blanc, should I say. Okay, so now we've got our a nice kind of clear view of the artwork. The wearer is looking around at the different faces on the artwork. So firstly, I might be interested in just generating a nice visualization of fixations, and that can give me a bit more information, maybe a bit more quantitative information. So I'm going to click toggle the fixations on. And now we're seeing, well, firstly, we're seeing a scan path, and we're seeing fixations that have been classified. we have an ID, fixation ID, which is a sequentially increasing ID associated with each fixation. We also have a circle, which the size of the circle is characterizing the length of the fixation. So that's nice. And another thing we might want to do is then map gaze from the scene camera. So currently, this gaze estimation is given within the coordinate system of Pupil Invisible Scene Camera, right? So the next step is to somehow understand that in the context of what is actually in the physical environment. Traditionally done with a frame-by-frame manual coding approach, and or sticking some kind of markers into the background, such that the system can automatically recognize those markers. We have a way to do that without using markers stuck in the environment, and we have a way to do that without manual coding. And I can show you what this looks like. If I click here and I jump into this side-by-side view. Okay, so now over on the right, we have a 2D image of this artwork, and we have gaze that has been mapped to this 2D image. And so on the left, the first person point of view of the scene camera with where the wearer is looking, and on the right, we've got the wearer's gaze that's been mapped to the image. So that's great. And how we're able to do this is we're essentially building a three-dimensional model of the environment. So this is visualized here by this point cloud that appears to be kind of glued to the environment, essentially. And we're able to use that 3D information, or that 3D model about the environment, to map gaze to a 2D representation of what the wearer is looking at. And this works not just with paintings, but you can do this with 3D objects. The more feature-rich the object or features of the environment are, the better, with good contrast and plenty of things that can be used to build that model. Okay, so
maybe I can interrupt you just for a second. How
sure.
did you get to this drop down where you say side-by-side view?
Okay, so there is a couple of steps that one would have to take to build this enrichment. But once you've run the enrichment, so you would, for example, jump into enrichment, create the reference image map. I can show you what that looks like now. Actually,
yeah, I think I've seen that step. I just kind of missed how you had this drop down and it said like side by side. Like since in the demo data it's already done, right? All of this work.
Yeah, that's right. So
once you calculate the enrichment, you select the section for the enrichment here in the sidebar that's highlighted. You have to pick that, right, Neil?
That's right. Yeah.
Standing. You click on that and you get the little bar that shows where the enrichment is. And when you're within this area, when you have this enrichment selected, you get the drop-down menu at the top left.
I get it. Okay.
Can you do toggle the side-by-side view? Fantastic.
So yeah, up in the top left here, you'll see scene view. If you expand that, you can get the scene view / reference image view.
But that's real detailed, and I know your documentation is very good. So sorry for stopping.
It might be lacking on this, but here essentially when you play it back, you really get to see, especially from the beginning, when the approach is from this oblique angle. To see how the 3D model
part of it, it's always amazing to me too.
Yeah, so that's nice. It's a really powerful way to do this kind of mapping. So they're looking away from the picture, obviously there's no gaze on the reference image. Then when they switch to the image, there we go, it's back again. And yeah, so that's awesome. And the great thing about this is once you have defined these events for one participant, let's assume that all of our participants have been through the art gallery and looked at this image. So you would open their recording, you would add in the same events. Christopher Blanc to start and Christopher Blanc to end when you create the enrichment, actually it's going to run the enrichment simultaneously on all of the participants' recordings, which is a great, this kind of analysis really lends itself well to the cloud, and we're able to do these aggregate or simultaneous mappings, and then generate aggregate visualizations and results. So the next thing that we might want to do is we might want to, let's say, build a heat map. So I can jump into, oh, 1 second. Here we go. Yeah. So if you were to expand, let's just do it from here, actually, because then you can see exactly the process that I've taken. So if I've computed the enrichment, I've checked out the side by side and looked at the mapping, and I'm happy with it. I might click on enrichments here, and these will all load. So these are all previously created enrichments that we've done. And again, you can have access to all of these. So we were just looking at Stephen's recording, and we were looking at the artwork, which was Christopher Blanc. So I'll find the Christopher Blanc enrichment. I'll select that. And in the top here, or you could right click on it. Let's right click on it and click heat map. So it's going to bring up an aggregate heat map of all of the, let me just move that bar out of the way. There we go. So this is an aggregate heat map of Anna, Jack, Michelle, Stephen, and Susan. The heat map's a 2D histogram of gaze points. So yeah, this is an aggregate heat map. If I want to filter it down and let's say look at Stephen, I can type in the bar here, Stephen, then the heat map's going to recompute with just Stephen's gaze. And you can see attention quite nicely on this face, more so on this person this face in the middle of the image here, a little bit less there. Similarly, if I wanted to filter down on somebody else, go to Susan, a little bit less attention in the middle the middle face. So again, you're getting nice higher level insights into different behavior of the different people who have been through the gallery in this case.
Amazing how far you already got to the advances in the automation. Moritz, we know you have to go and take care of family. Wish you a great, nice weekend, and thanks for being here, Moritz. And
thank you so much for having me.
We'll stay a little longer, and
yeah, please do.
We'll let you go. Take care.
There's the opportunity to talk to Neil. He'll be able to answer any questions.
Awesome. I'm already.
Thanks from the Kunsthalle also. It was really great.
Thank you so much. Have a good day. Bye.
Bye.
Bye, Moritz.
Bye. And
bye.
So we now kind of interrupted you, Neil, but maybe it's also, since you're a real expert, and of course we're happy to learn about the cloud more. Maybe we'll just take one step back again and see if there was another question, or you guys in the audience. I know this mobile eye tracking, of course, if you have never used it, now this might be a little overwhelming. The different settings that we use it for, like in the applied research, we like to call it. And I know, Neil, you have used it a lot, even for the real scientific research. There's many different settings. So our clients like to use it while doing research in a car, while either simulator or in the real world. We like to use it in shopping environments. That makes a lot of sense for us. And also in the at-home environments now, since Moritz explained it so easy, we can actually send a nice package that you guys make, like how the Pupil Invisible is delivered, and send it to a person who doesn't even know what eye tracking is. And that's for us like the most exciting step as researchers. And then we call them and we say like, okay, can you put it on? Can you bring the phone into your home Wi-Fi? And in this setting, then we ask the respondents to, let's say, watch TV for an hour. So they should put it on, go to the sofa, and then it's media research, right? And our clients from Google to Facebook, or also the TV companies, like to do that because they want to understand the natural behavior. of people really sitting at home and not in the lab. And so there's a variety of settings where we collect data. And through the cloud, we have the benefit that it's being uploaded through the person's Wi-Fi. And all we have to do is give them the Pupil Invisible and a kind of normal Android these days. We tend to deliver it together because it's just safer that it works. But it's the first time really for us that we can do that. And you guys made it possible. And the cloud is for us researchers, right? So the respondents, the participants, they don't look into the cloud. This data is being uploaded automatically. That's right, right? Is it just uploaded to the cloud?
Yeah.
And there was actually the question, is there a restriction for capacity for a single user in the Pupil cloud by Sabrina?
Currently, no, we don't have a capacity for how much you can store in the cloud. Yeah, and so there will always be a free storage option regardless.
Yeah, that's really cool. And I understand, I mean, there is a big cloud that you have to take care of, and we leave our data on the cloud even for a long time, even though sometimes we shouldn't. We tend, of course, once a research project is finished, we have to download and delete, and that works fine. Downloading is probably the more expensive part, as far as I understand this whole cloud world. But if possible, and if these aggregations, like you just showed, can be done in the cloud, we don't even need the videos anymore, right? We can just delete them. But as researchers, we actually like to look at them, and they give us so much insight. And one great enrichment that we like a lot, and I think it's one we asked for very early, is the one to detect faces. And once the face is detected, it's of course easy to blur it or like put a mask on it or something, because then we're actually in the GDPR safe side, as long as we don't have any pupil data, which we don't access anyway. We can only see these videos and no audio and no faces, then we can store it forever. And there was another question. I hope it's okay when I ask a question about troubleshooting. We have some issues with the companion device starting to get hot and then constantly vibrating during the recordings after a few minutes. Is this a common issue, or can we tackle this? Actually,
yeah.
we don't have that problem in this current study, but I guess it depends a bit on the device.
I'd say firstly, are you using the 1+6 or 1+8?
Yeah, that would be a good question.
I guess we have the Pupil Labs for like 1 or 2 years, so probably it's the older one, I would guess.
Yes, it will be more than likely. Yeah, it'd be the 1+6. Why don't you reach out to info@pupillabs.com and we can try to investigate a little bit further. So there's a few like things you could try within the companion app itself. Firstly, there's in the settings, there is an option to toggle or enable or disable iVideo transcoding. So basically what that means is if it's enabled, the videos are transcoded and they take up less storage space. However, it uses more computational resources, which can make the phone hot. The companion device will start to get hot or warmer, shall we say. So you could try disabling that.
Yeah,
and
good point.
And after a couple of like years, so has it been in a lot of use, dynamic situations and things, the glasses and the phone? I'm just thinking of USB cables and wear and tear. So if there are small disconnects with the USB cable, sometimes that can lead to the vibrations as the USB is being reconnected, basically. So that's something that we can help you debug if you reach out. Yeah, reach out to info@. We can give you some tips on how to debug that. Maybe even have a video call to help you with it.
Okay, thanks so much.
No problem.
Thanks, Neil. And you guys have helped us a lot as well with debugging and finding these problems. And the switch to the newer phone generation definitely helped us a lot. And I know in this last study where we shipped so many devices for this in-home study, we definitely made sure they're all the same all standardized, and all the cables are like the latest ones, since the USB cables there, we know all, they make a big difference also in charging and the time it's used for charging, and that's definitely cool. How long would you say a recording should be, Neil, or maximum time? I said something about an hour here, but I don't know why I actually picked that up.
In actual fact, we can record for up to 150 minutes on the OnePlus 8 phone. And so if your testing needs that, then it's, technically possible. And yeah, that's what we're kind of, a lot of work went into making the system able to do these longer recordings, because it was difficult to do previously in dynamic mobile settings, right?
Oh, yeah.
So that's what we want to kind of enable. We want to empower people to be able to do these longer recordings. So yeah, 150 minutes is the pretty much what happens. Technically, you could go for longer. However, what happens is the battery will run out on the phone. Yeah.
But it's still, I mean, I don't want to complain or anything. And since we have you here, like, what do you think is like the most exciting for you, like as an expert advancement you're either working at? If it's secret, of course, you don't have to share, but what do you like best? Like, what gets you most excited about the product and the development these days?
Being able to use this system in very dynamic situations and actually get robust gaze estimation. So I spent 6 years in academia. I retain links to academia and still research active, but I'm not really hands-on with the kit these days. But when I was doing it, I was using a few different systems, including Pupil Core, and I was measuring people walking around in the built environment, going up and down stairs, and then integrating the data together with biomechanical data, human movement, motion capture, and things like that. And using traditional calibrated eye tracking in those dynamic contexts is possible, but very challenging, keeping on top of the calibration and so on. So the most exciting thing for me is to be able to just put the glasses on and wear it and have them walk around for an hour and not have to worry about calibrating. I mean, case in point, I went a few months back. I was at one of my old institutions in Lancaster, and I took 2 people invisibles with me, and gave one to one of my older colleagues, my old PhD supervisor, and I took the other one, and we collected 2 parallel groups of students playing basketball, the others playing football, had them do various tasks, penalty kicks, free throws, and then actually had gameplay. And my PhD supervisor is an expert in biomechanics, but not practiced in eye tracking at all, not well versed in eye tracking, no real experience in it, and he was able to use the invisible system and collect half a day's worth of data, and we didn't lose any recordings, and all of the data looked good, which 4 years ago was kind of an unthinkable thing. Pretty much. Yeah.
Data loss is a great example.
Yeah.
And maybe I can ask you just one more question, then we also don't want to keep you too long. I sometimes forget to look into your cool Pupil Labs blog, and you do a very good job also to curate it. And which story would you say is definitely worth reading? I like from the pictures, I really like this one with the 3D stuff, but do you have a favorite?
The 3D one is actually a really interesting one, because it's essentially the researcher has used Pupil Invisible, but with the addition of depth sensing to reconstruct spatial gaze basically into the environment of the wearer. So
V-SLAM,
it's technically very challenging to replicate that, but really awesome what can be done. Yeah, that's a beautiful, like, there's some beautiful visualizations, and it's just a great read.
Kind of reminds me of what Moritz and Will did in their very early thesis.
Yeah,
but that goes back a couple of years.
Yeah, and I would also recommend, if you're interested in, well, a lot of these are actually kind of focused on Pupil Core. So the baseball one that's showing now, that's a pupil core study, which is interesting in and of itself. But I really like the motorbike feature. So right at the top, the ahead of the curve. So we did a community piece with Bennett's Motorcycle Insurance, and they took expert, novice, and like social motorcyclists and put them on a racetrack, and measured their gaze. And again, the operator, it was a case of send them the eye tracker, and they were able to collect the data. And it's nice because even though they didn't really know what they were going to find, it was quite clear that the experts are adopting very, very different gaze patterns when compared to the novice rider. And it just shows really nice. It's definitely worth watching and reading the actual feature.
Cool. Thanks so much. And I guess the participants have a lot to digest now anyway, and to be able to find all of the information. We'll send an email to all of you, so don't worry, you'll get the information, and the email info@pupillabs.com I already posted, and maybe I'll give the audience another chance to raise your hand or just unmute and post a question. You can also write it if you don't feel like speaking. And are we able to use these examples? So Ephraim is asking this. So I guess if you want to use an example from the Pupil blog, I would say yes, use it. If you say it's from the Pupil blog and that you have made it yourself, so citing in a correct way, yeah. And you can find it on pupillabs.com on the blog. And I think that's hopefully answers this question. And yeah, the demo data that you have put online, would we also be allowed to showcase it as long as we kind of say this is the Pupil Labs demo data, or how would you?
Yeah, absolutely. If you want to show people that, please feel free. Yeah.
Cool. And the motor example could use to speak with auto insurance companies. Yeah. So Ephraim is definitely thinking of this example. It's on YouTube, so Ephraim, you can show it to them definitely, and then you can tell them it's a Pupil Lab case study. Cool. Neil, I know you still have some work to do, and we want to thank you so much. And so we'll let you go and say thanks to all of the participants, and wish you a great weekend.
Awesome. Thank you very much.
Take care.
Bye-bye.
Take care, everyone.
Awesome. Thank you.
Thank you, Jeff.